All right, let's talk about the moment that changed everything for AI. Picture this. It's 2017. A handful of researchers at Google published a paper with a kind of, well, a deceptively simple title. But inside was one single radical idea that would completely blow the doors off the old way of doing things and honestly, unleash the AI revolution we are all living through right now.
So it really all boils down to this one question. Because before this paper, AI was getting pretty good for sure, but it had slammed headfirst into a very, very frustrating wall. And to really get why the breakthrough was so huge, you first have to understand the wall they were all up against.
So, let's set the stage. We're talking pre-2017. AI is getting pretty good with language, but it has this fundamental problem. It's like there was a speed limit baked right into its DNA.
And that problem? It had a name, the sequential bottleneck. You see, the entire world of language AI was dominated by this one type of architecture that was, well, both brilliant and deeply, deeply flawed.
So meet the old kings of the castle, recurrent neural networks, or RNNs. And their whole design was actually pretty intuitive. They were built to work the way we read, one word at a time, in order. The model would read the first word, kind of hold it in its memory, read the second, update its memory, read the third, and so on, right to the end of the sentence.
But here's where the whole thing falls apart. Processing word by word is just painfully slow. And just like us trying to remember the first chapter of a book by the time we get to the last, the RNN's memory would fade over long sentences. It really struggled to connect a word at the end of a paragraph back to something important at the beginning. It was like trying to read a whole novel through a tiny pinhole. You only see one word at a time. And the worst part? You couldn't just throw more computers at it to speed it up. It was fundamentally stuck. AI had hit a massive wall.
And then this paper drops. The solution from 8 researchers at Google proposed a totally new way of thinking. They didn't just try to improve the old method. Nope, they threw it out. The whole thing.
I mean, just listen to the sheer confidence in this quote from the paper. Dispensing with recurrence and convolutions entirely. Think about that. They were basically saying, hey, you know that entire foundation that the whole field of language AI is built on? Yeah, we're getting rid of it. And they were replacing it with this one single idea, attention.
So what is this magical self-attention? Well, instead of that tiny pinhole view of RNNs, self-attention gives the model a bird's-eye view. It lets the model look at the entire sentence all at once, and for every single word, it can calculate how important every other word is to its meaning. It can instantly connect it way over here back to the robot from 3 sentences ago. The distance just doesn't matter anymore. It sees all the connections at the same time.
Okay, so let's pop the hood on this new architecture. How on earth did they build a model that could see everything at once without it all just becoming a big jumbled mess? Let's take a look inside the transformer.
At its core, it's an encoder-decoder model, which is a pretty standard setup. The encoder's job is to read and really understand the input sentence. The decoder's job is to take that understanding and generate the output, like, say, the sentence in a different language. The truly revolutionary part, though, is that both the encoder and the decoder are built almost entirely out of this powerful new self-attention mechanism.
And they didn't stop there. They made it even more powerful with something called multi-head attention. Now, this is just genius. It's like having 8 different experts all read the same sentence at the same time. One expert might be focused on grammar, another on who did what to whom, a third on just the general vibe of the sentence. Then they all combine their notes to get this incredibly rich, multi-layered understanding of the text. And here's the key, because they're all working in parallel, it is ridiculously fast.
Okay, but wait a second. You might be wondering, if you look at all the words at once, how do you know what order they were in, right? The dog bit the man is a very different story from the man bit the dog. They solve this with a really clever trick called positional encodings. Essentially, they just add a little piece of math, like a timestamp or a GPS coordinate, to each word that tells the model its exact position in the sentence. So simple, but absolutely critical.
So the billion-dollar question. Did it actually work? I mean, the theory was elegant, sure, but could it really beat the old methods that had been refined for years and years? Oh boy, did it ever.
This number right here is the hero of our story, 28.4. That was the new record, the new state-of-the-art score on a really important machine translation benchmark. And the transformer didn't just inch past the old record, it blew it out of the water by over 2 full points.
In this field, that's not just a win, that's a knockout.
Now, what's really wild is this last column. Just look at the chart. Not only did the transformer get a much higher score, it did it using way less computer power. Look at that training cost. It's almost an order of magnitude cheaper to train than the best Google model from the previous year. It was better, faster, and cheaper. That's the Holy Trinity. That just never happens.
And it wasn't a fluke, not at all. They pointed at another task, English to French translation, and it did it again. It set another new record after just 3.5 days of training on only 8 GPUs. I mean, this was a level of efficiency and power that nobody had ever seen before.
So this is where we connect all the dots and bring it back to the world we live in right now. Because this paper wasn't just about making translation a little bit better. It was about forging a new, fundamental building block for all of artificial intelligence.
And this right here is why this paper from 2017 matters so much to you today. You've heard of ChatGPT, right? Well, that T in GPT, it stands for transformer. The architecture laid out in this one paper is the direct ancestor, the granddaddy, of BERT, T5, and yes, the entire GPT series of models that have taken the world by storm. Pretty much every major leap forward in AI since then has been built on this exact foundation.
So that simple, beautiful idea to just pay attention, solve the massive problem of context, and broke down that sequential wall, allowing AI to scale up in a way that was literally impossible before. And that leaves us with the big question that researchers are racing to answer today. What's the next wall? What is the next fundamental bottleneck that AI needs to smash through to take the next great leap? That's what we're all waiting to find out. Thanks for joining me for this one.